So values of tangents, remember on the unit circle, if we're taking each angle and then using the coordinates when we draw the triangle, it ends up being the opposite side over the adjacent side, right? So if I had, let's say we have an XY grid, and I draw a triangle here, brings us to a point on our unit circle, x comma y. The x coordinate is that horizontal leg, the y coordinate ends up being that vertical leg. And with tangents of theta being opposite over adjacent, we get that to be y over x. Okay, so that's the easiest way to find those values of tangent is to take y over x at each kind of rotational amount. Okay, so the values that you should end up getting, we actually get some undefined values, and that's going to happen at negative pi over 2, positive pi over 2, and then again at 3 pi over 2. Why do those values end up being undefined? Good, because of division by 0, right? And we've now seen this multiple times, right? With graphs of secant and cosecant. We got vertical asymptotes because of division by 0. Okay, same thing with rational functions, division by 0, vertical asymptotes. Log functions, we got vertical asymptotes, but that was for a different reason, but more kind of in general, it's whenever we have domain restrictions. Yeah, Caroline, what you got? All right, then your values in between, this is going to be 0. That should be negative 1, 1, negative 1, 0, 1. All right, so we're going to come up with basically a set of rules here for how we're going to graph this tangent function. Most of it's going to be based off of where our asymptotes are located. So that's kind of the main focus for how we're going to graph tangent, is focus on the asymptote. So we're going to, our kind of starting asymptotes are here at negative pi over 2 and positive pi over 2. And I want us to make a note of that the parent function, so parent of tangents, theta, has starting asymptotes at x equals negative pi over 2 and x equals positive pi over 2. Okay, and the reason I'm having us make that note is this is what we're going to focus on in graph tangents. Okay, we're not going to really use that idea of the period, even though the period's still going to show up here. But we're not going to use that idea of the period that we use with sine, cosine, and then secant and cosecant. We're going to focus more on these starting asymptotes. And the main reason for that is because we get so many of these vertical asymptotes, if we took the same approach that we did with like sine, cosine, and plotted the function without the phase shift, then applied it with the phase shift, we would just get so many vertical asymptotes and so much graph here, it'd be really hard to tell what we're actually trying to graph. Okay, so basically what we did for sine and cosine, know that we're going to do something different here. All right, so we find our starting asymptotes, and then halfway in between those asymptotes, so our half period, we will always be on the midline. And then from here, we're going to use the a value. And just like with secant and cosecant, amplitude doesn't apply to the tangent function because there's not going to be a maximum or minimum. You'll see that here in a second. So our next set of points happen at the quarter and three-quarter period distances. And those distances will always end up being halfway in between the midpoint and the asymptote on both sides. So if I go to this right quarter point, halfway between the midline and the asymptote, I'm going to go up by the a value, which in this case is 1. And I can check that. Okay, this angle measure, this x value is pi over 4. At pi over 4, I get a y value of 1. And I do the opposite at that left quarter. So I'd go left quarter and then down by the a value, which is 1. And so that's negative pi over 4, which gives me a y coordinate of negative 1. And then the graph ends up looking like almost like a cubic function. And then it just repeats in both directions. So then, well, first, what's the period here? Well, let's draw on another cycle. Maybe we'll see a little bit better there. Okay, because based on these points here, we see I have another asymptote at 3 pi over 2. Halfway between those asymptotes, we're on the midline. And again, all of these points can be checked from what we found in the table. And so this graph repeats again. So how long does it take for a graph to repeat here, Monty? Pi, exactly. And that's a big difference from what we saw with sine and cosine. So the period here is just simply pi. Okay, and with sine, cosine, secant, cosecant, the period was 2 pi. Okay, so that's one of the major differences. All right. Well, that's basically all. Well, actually, the last thing I want to talk about is why is the period pi here? Because when we think about, so I don't know that I explicitly shared this with us, but when we graph sine, cosine, basically what we're graphing is if we pretended like we are moving around the unit circle, we're plotting values as we move around the unit circle. Okay, and that's what the graph of sine and cosine is modeled, as if we started at positive x or at 0 radians, and as we rotate based on those y values we get, it creates the sine and cosine function. So all these tangent or all these trig functions, when we graph them, model us moving around the unit circle. Now, if we think about that for tangents, well, for tangent in quadrant 1, tangent is positive. In quadrant 2, tangent's negative. And then that repeats once we get to quadrants 3 and quadrants 4. So in quadrant 3, tangent is back to positive. And so we get the exact same values that we'd get in quadrant 1 for tangent. And then in quadrant 4, tangent is back to negative. And so we'd get the exact same values that we'd get in quadrant 2. Okay, so that's why the period is just pi, because in quadrants 1 and 2, we have the same values we'd end up getting in quadrants 3 and 4. Okay, so the next thing I want to do is just identify the transformations in the equation. We're not going to graph cotangent in here, even though it's not much different. That's something you'll do when you take pre-calc. So this, for us, is just going to apply to tangent. And I did actually change this a value. Remember, I kind of made that mistake with the secant notes and homework, and that amplitude doesn't apply because amplitude is distance from midline to a maximum or minimum, and there is no max or min here. Okay, so the a value is just simply a. It vertically stretches or compresses our graph. It could even be a place where we see a reflection. The period is going to be pi divided by b. With all our other functions, it was 2 pi divided by b. The phase shift is still c, and the vertical shift is d. Okay, so we'll still identify all these key features, but like I said, we're going to go about graphing these a little bit differently. So let's start going through some examples, and I have 3 for us to do. Just like yesterday, I'll do the first one, have you all do the second, and then we'll finish by going over the third all together. Okay, so let's identify some of these things. That a value here is 2. Because it's not amplitude, I don't need to take the absolute value of it. It's just simply 2. The period is pi divided by 2. And that's going to change where our starting asymptotes are. And I'll share how we're going to basically find those, because we're not going to really, we're going to take a different approach than we did with sine and cosine. All right, phase shift, there's none. Midline's at y equals -1. And this is where we're going to do our work to find the asymptotes. So for every tangent function, what we're going to do is take whatever's in the parentheses, which includes the value of b, so the value that affects our period. And then if we have a phase shift, we're going to include that as well. So we take what's inside the parentheses, and we set it equal to the starting asymptotes for tangent, which are at -pi/2 and then +pi/2. And then we solve for theta. And by us solving for theta, we're going to get the location of our new asymptotes, which again accounts for the period change as well as the phase shift if we have one. So to get theta by itself, I need to divide both sides by 2. And that makes theta equal -pi/4. And then theta equals +pi/4. So on this graph, pi/4 is just the first tick mark on either side of the y-axis. The midline is down 1. I like filling that in just because it's really easy to forget that. Like, my temptation is to put my midline point on the x-axis, but it is based on that vertical shift. Okay, and so now we have everything set up for us to graph this function. I'm going to put a dot on the midline, halfway in between my asymptotes, and then we're going to use the a value at the quarter marks, okay, which is halfway in between the midline point and the asymptote. So if I go right by a quarter, or right halfway in between the midline and the asymptote, I'm going to go up by the amplitude or the a value, which is 2, and then the left quarter down by the a value. And one thing I want to point out here is the distance between the asymptotes is our period. So let's just make sure that's pi over 2. Well, this is 1 pi over 4 plus a second pi over 4, which does make this pi over 2, which is our period. Okay, and then let's, for all these tangent graphs, when we can, let's try to fit about 3 cycles. So let's just graph one more cycle on either side of this here. So one where it's positive, one where it's negative. And our asymptotes are every 2 squares. And then there's no difference between one cycle to the next. All right. Well, let's have you all work through B. Should be very similar. Your period's going to be something different than what it started with. And you know what? I meant to change this value. This needs to be theta over 2. Make that theta over 2. That way it just fits the graph a little bit nicer. All right, give you a couple minutes to do that. So on this graph, because our period ends up getting longer, which as a transformation, that ends up being a horizontal stretch, right? And we're clearly seeing that here, right? Those asymptotes have been pulled apart horizontally to be much further than they were in that parent function we did on the front there. Okay, so your asymptotes, after taking everything in the parentheses and setting it equal to the starting asymptotes, end up at negative pi and positive pi. Always a good idea after you do that to make sure that that matches what your period is, which is 2 pi, and I'm clearly seeing that here. Okay, then I know that my midline point is right in the middle, and what did I forget about? Everybody, what did I forget about? The vertical shift. Okay, right, I did not shift everything up 1. Okay, so I'll just use a different color and shift everything up 1. This is why I add in the our new midline, because it's so easy to forget. And I even said that when we did the last graph, so silly old me. Should be that black line. Okay, the one that shifted up 1. But that's, again, why we're kind of taking a different approach. When we add in more than one line, it can be kind of confusing to tell which one we're actually trying to graph here. Okay, everyone good here so far? All right, let's do one last one. This last one is going to include a period change and a phase shift. Nothing changes how we're going to approach this. Okay, we're going to, again, take everything in our parentheses and set it equal to the starting asymptotes and find where the new asymptotes are and let that drive how we graph the rest of this function. Okay, so let's fill out all of these kind of key features here. The a value is -1, which is a reflection. Okay, specifically a reflection across the x-axis. The period is pi divided by 1/2, which is 2 pi. The phase shift, the most common wrong answer here would be right by pi over 4. However, this needs to get factored out. Okay, so I need to take theta over 2, which we know is really 1/2 of theta, minus pi over 4. And I need to divide to get theta to be +1. So I'm going to take out this 1/2, and that makes this 1/2 theta minus pi over 2. Okay, if you do this division, pi over 4 divided by 1/2, you get 2 pi over 4, and that's how I'm getting negative pi over 2. So our phase shift is taking everything right by pi over 2. The midline's at y equals -1. I'm going to add that in just right now so I don't forget. And then the asymptotes, again, we're going to take everything in the parentheses. Now, I've seen some students take this kind of factored out B value and then our actual phase shift and set that equal to asymptotes, and that's fine. You have to include the 1/2 though, because those asymptotes are affected by both the B value, which changes the period, and then definitely by the phase shift. So we need to either take theta divided by 2 minus pi over 4 or 1/2 times theta minus pi over 2 and set those equal to our starting asymptotes. I just almost always use what we started with in the equation. So I'm going to take theta divided by 2 minus pi over 4, set it equal to negative pi over 2, and then again, setting it equal to positive pi over 2. So I need to get a common denominator when I go ahead and add these. So theta divided by 2, that would be negative 2 pi over 4. I'll just write it all out. Negative 2 pi over 4 plus 1 pi over 4, making theta over 2 equal negative pi over 4. And then to get rid of dividing by 2, I'd multiply everything by 2, making theta negative 2 pi over 4, which reduces down to negative pi over 2. So that didn't move. Seems weird. Because it got shifted but then stretched. So I'm not going to conclude. I feel like everything on my algebra matched up. Let's just make sure when we do this second asymptote that we at least see a distance between the asymptotes as being 2 pi. Okay, so let's solve for this next one. Same deal here. This is 2 pi over 4 plus 1 pi over 4. So theta over 2 equals 3 pi over 4. And then when I multiply by 2, that makes that 6 pi over 4, which reduces down to 3 pi over 2. And so then is our distance between negative pi over 2 and 3 pi over 2 2 pi? It is. Okay, so everything seems to match up, even though it feels a little odd that this left asymptote is staying at negative pi over 2. Everything's good. All right, so negative pi over 2 is that left asymptote. Positive 3 pi over 2 is the right asymptote. And then halfway in between these asymptotes will be on the midline. So that's going to be moving 1, moving 2, moving 3, moving 4. 1, 2, 3, 4, 5, 6, 7, 8. So what is that right in between pi over 2 and 3 pi over 4? Is that where we're finding that middle to be? Or am I slightly off on that? In 1, in 2, in 3. Or is it exactly at pi over 2? Exactly pi over 2. Because it should be pi. 2 pi over 2. Yeah, 1 pi over 2. And then the right quarter, well, now that we have a reflection, instead of me going up, now that point's going to get reflected. So now I'm going to go to down when I use that A value. Yeah, go ahead. Am I something off here? What's that? On the midline? Good call. This time I even had it drawn on there. Good call. All right, so right quarter, again, instead of me going up, that point has now been reflected, so I'm going to go down. And that right quarter is at pi. And then the left quarter is at 0. And that's where I'm going to go up 1. Once again, we really only have space to do 1 cycle, so we don't need to add in any more. Okay, well, that is it for